Up till now, you've been drawing graphs of sine and cosine, and we've been really focusing on sine and cosine. So for instance, right here over my shoulder, I have a graph of one period of sine. Notice starting at the origin, then at pi over 2, we're at a height of 1. At pi, we're at a height of 0. At 3 pi over 2, we're at a height of -1. At 2 pi, we're back to a height of 0. So here's one period of regular old plain old sine. And what I'd like to do is I'd like to look at a graph that's very related to sine, which is cosecant. Now remember from when you studied the unit circle and you studied the 6 trig functions, you know that cosecant of an angle is 1 divided by the sine of that angle. So they are reciprocals. Now what that means is that when you draw a graph, the graph of cosecant is going to have to be very closely related to the graph of sine. And so now I've already typed into Desmos cosecant. I'm going to go ahead and turn that on so we can look at what's going on. So here in green, we see the graph of cosecant. And you'll notice that they meet up perfectly right here, and they meet up perfectly right there. In fact, it's like they just come up to each other and they just kiss. And then they peel away from each other. And as sine gets lower and lower, you'll notice cosecant is getting higher and higher. Here's sine again getting lower and lower. Here's cosecant again getting higher and higher. Then something happens. Right around in here, something happens. And as sine keeps getting lower, well, cosecant keeps getting higher and higher, but it's not getting higher and higher over here anymore. It's suddenly getting higher and higher down here. As secant gets lower and as sine gets lower and lower right in there, cosecant is getting higher and higher. Here's sine getting lower and lower. Here's cosecant getting higher and higher. So what happened right here in the middle? Well, right here in the middle, the graph of cosecant is actually ripped in two. And in fact, there's a barrier right here. As sine approaches 0, cosecant, remember, is 1 divided by sine. As sine is getting closer and closer to a height of 0, secant is 1 over sine, getting very close to 1 over 0. And we know from elementary school math that 1 over 0 does not exist, undefined. So right here, when x is pi and sine is 0, cosecant is undefined. And then when sine is negative, well, 1 over a negative is a negative, so now cosecant is suddenly negative. And as sine gets lower and lower and lower, secant gets higher and higher and higher. And then right here again, they kiss just for a moment right there at 3 pi over 2, -1. And then they start heading back down again. What happens right here at 2 pi? Well, again, sine is 0 at 2 pi, so cosecant gets torn. Cosecant can't exist there. And the same thing happens over here where x is 0. Since sine is at a height of 0, cosecant, which is 1 over sine, does not exist. And in fact, we can even add lines to show those spaces right there. You'll see right there, I've just added in purple. Here's the line x equals 0. Here's the line x equals pi. Here's the line x equals 2 pi. And you can see how cosecant is getting close to those lines. Cosecant is getting close to those lines, but not touching them. Those are the asymptotes of cosecant. Now, what if I were to change this out a little bit? Let's turn these off. And let's turn sine into cosine. Okay, so now we have a graph of cosine. Cosine, remember, when x is 0, cosine is 0. When we get to pi over 2, when x is 0, cosine is 1. When we get to pi over 2, x is 0, cosine is 0. When we get to pi, cosine is -1. When we get to 3 pi over 2, cosine is 0. When we get to 2 pi, cosine is 1. So what do you expect the reciprocal of that to be? Well, the reciprocal of cosine, we know from looking at right triangles, the reciprocal of cosine is secant And we expect the same kind of behavior to happen here that we saw happen just a minute ago with sine. So right here, you'll notice cosine has a peak. I'm expecting that secant is going to just barely touch it right there. Right here, cosine is at 0 height, so I expect there to be an asymptote right there. Right here, cosine is -1. I expect secant to come up to rise to touch it. And right here, cosine is 0, so again I expect an asymptote because 1 over 0 doesn't exist. And then right here, where cosine equals 1, I expect secant to come down and touch it. And let's find out if I'm right. So now I'm going to go over here to Desmos and I'm going to type secant, S-E-C, and sure enough, here sine is at its peak, secant hits at its bottom. Here, cosine is at its bottom, secant is at its top. Here, sine is at its top, secant is at its bottom. And you can see right there at x equals pi over 2 and at x equals 3 pi over 2 that the graph has asymptotes. The graph approaches this line but does not touch it. The graph of secant approaches this line but does not touch it. Okay, so let's take that idea and now we're going to get away from using Desmos and we're going to do something much more similar to what we've been doing in class recently. I want to try and graph one complete period of one of the trig functions. So I'm going to try and graph one complete period of y equals, I've got it written down right here, folks, 5 times the cosecant of 4, open parentheses, x minus pi over 2, add 2. Now, the trick to drawing this is that for just a minute, instead of drawing cosecant, I'm going to graph sine. Remember, cosecant of an angle is 1 over the sine of that angle. So the trick to drawing cosecant is actually to draw sine first. So for the moment, pretend that doesn't say cosecant. Pretend that says sine. Then this 5 would be the amplitude. This is a 4, so that means the period is 2 pi divided by 4, which is pi over 2. We have a phase shift of positive pi over 2. Remember, it's the opposite of this. And we have a vertical shift of plus 2. So if I want to draw my box like we've been practicing, here is the center of my box. Here's the top of my box. Here's the bottom of my box. The baseline, the center line is at 2 because that's my vertical shift. Y equals 2. My amplitude is 5, so I'm going to go up by 5, which means that this is 2 plus 5. Y equals 7. My amplitude is 5, so I'm going to go from 2 down by 5. 2 down by 5 puts me at y equals -3. And that's the lowest my graph goes. Then lefty-righty, my phase shift is pi over 2. So this vertical line right here is x equals pi over 2. And then remember my period. My period, I said just a minute ago, was 2 pi divided by 4, which is pi over 2. So to get where my cycle ends, remember, you always take your phase shift and add your period. My phase shift is 1/2 pi, plus my period is 1/2 pi. 1/2 plus 1/2 equals 1. So right here, x equals pi is my end of one period. So now I want to draw sine. Notice that the 5 here is positive, so I'm going to be drawing sine right side up. I've got my number line divided into 4 equal pieces. And when we draw sine, sine always starts at the middle. Then when we get to 1/4, sine is at the top. I get to 2/4, sine is at the middle. I get to 3/4, sine is at the bottom. I get to 4/4, sine is at the middle again. And so here is my graph of sine. Now that's just like what we've been practicing. But now it's time for me to stop and remember that I'm not really graphing sine. No. I'm graphing cosecant. How do I take this box and I turn it into a picture of cosecant? Well, where sine fits exactly inside the box, cosecant is going to be exactly outside the box. So, let me grab another color. Right here, sine is touching my horizontal center line, so that is where we're going to have an asymptote, right there. We're going to have an asymptote. Right here, sine is touching the center line, so that's where we're going to have an asymptote. That's where we're going to have an asymptote. And right here, sine is touching the center line here at x equals pi, so that's where we're going to have an asymptote. That's where we're going to have an asymptote. And cosecant now, well, cosecant needs to just barely touch sine. So here's where sine's at its top. That means that needs to be the bottom for cosecant. And right here, that's the bottom of sine. So that needs to be the peak for cosecant. Remember, the asymptotes are barriers I can't cross. And now, when I want to say that this is a picture of cosecant instead of sine, well, now that I've drawn cosecant, I'll just go back and I'll pretend I never drew sine at all. So you see, the secret to drawing cosecant is instead draw sine instead. Now, what about asymptotes? What if I'm taking a test and they ask me where are the asymptotes? Well, we know that there's an asymptote at pi over 2, and we know there's an asymptote at pi. But what about this asymptote right here? Well, this asymptote has to be exactly halfway in between that one and that one. And the way to find where something is halfway is to average the two numbers. So over here I have pi over 2, and over here I have 1 pi. To find out where this is, I'm going to average those two numbers. Now, of course, to average two numbers, I have to add them together. So I have pi over 2 plus pi. And then after I add them together to get the average, I'm going to divide by 2. So pi over 2 plus pi is 3 pi over 2. And then I need to divide that by 2. 3 pi over 2 divided by 2. Well, remember, you can think of that 2 as being 2 over 1. So this is 3 pi over 2 divided by 2 over 1. How do I divide by a fraction? I flip and multiply. So instead of 3 pi over 2 divided by 2, I'm going to think of it as 3 pi over 2 times 1/2. And now I just multiply straight across. 3 pi times 1 gives me 3 pi. 2 times 2 gives me 4 in the denominator. So now I can tell you that this dashed line right here is located at x equals 3 pi over 4. X equals 3 pi over 4, exactly halfway in between the other two. What if the problem had you do secant? Well, you would do the same logic, except instead of using sine in place of cosecant, if I'm doing secant, I would do cosine in place. And so I would draw the cosine graph. And then, just like we did with sine, everywhere the cosine has a peak, the secant would have a valley. Everywhere that cosine has a valley, secant would have a peak. And everywhere that cosine crosses the center line, that's where you would draw your vertical asymptotes. And so the secret to drawing cosecant and secant is just remember that first you draw sine or cosine, depending on who matches up. Now it's time for you to try.